Let's graph this. Find the x and y intercepts. Iser, how did you write this with x's and y's? Raise your hand if you wrote that. That was yesterday's lesson, right? Instead of having x's, we can have different variables like t. Instead of a function h of t, you can write y. Ashley, how do you find an x-intercept? So to make an x-intercept, what value are you making 0? The y. So that becomes 0 equals 2x minus 3 over x plus 5. Here you have a fraction equals this. You can make it a fraction and you can do cross multiply. That would be fine, so I'll show you that. So 0 times x plus 5 equals 1 times 2x minus 3. Zoom in for you. Class, 0 times anything? 0. So 0 equals 2x minus 3, because I don't really need to distribute the 1. Add 3 to both sides. 3 equals 2x. Divided by 2. X equals 3 halves. Remember, that's an order pair. 3 halves, comma, 0. Your x value is 3 halves. Your y value is 0. Raise your hand if you got that. That was yesterday's lesson. How do you find a y-intercept, Nicole? We're going to make x equals 0. So I'm just going to have y equals 2 times 0 minus 3 over 0 plus 5. Class, 2 times 0?
0.
Don't have to write it. So I have negative 3 over 5, which is negative 3 over 5. My order pair is 0 because we made x equals 0. And then the y value is negative 3/5. Raise your hand if you got that. Good. Okay. Let's graph it. I'm going to press clear. Remember, you want to have x's and y's for your calculator. So just change it. Everyone say parentheses. You need lots of parentheses. So I'm going to put a parentheses for the numerator divided by a parentheses for the denominator. So parentheses 2x minus 3, close parentheses, divided by parentheses x plus 5, closed parentheses. What buttons do we always press next? Zoom what?
6.
6. Because I want it to reset. What is this graph? Oh my goodness, nothing I've ever seen before in my life. Let's say if we change the y minimum and y maximum. Let's say if we go higher, let's just see if it changes something. Y minimum, let's change it like, I don't know, negative 100 to positive 100. Count by tens. That graph is just like out of the world, right? Press graph. Oh.
Oh my god.
What is this? Now, this is why the lesson here is called graphing failure. Everyone say that.
Graphing failure.
It looks like the graphs are touching, aren't they? But watch this. If I make this denominator, if I make x equals negative 5. Class, if I made this negative 5, class, what's negative 5 plus 5?
0.
A number divided by 0 is equal to undefined. This is bad. If you have 0 divided by a number, 0 divided by 4, that's 0. That's good. You can do that. So, what I'm trying to show you is this. Your graphing calculator actually fails. It shows you that the graph is actually connected, and in real life, it is not. We'll learn later on that this green line is called an asymptote. Everyone say asymptote? Some people say, don't touch my ass. Mintote. The graph will not touch this. Okay? Again, the calculator looks like they're all attached because it has limitations. Okay? Now we can just finish up our graph by putting this one, 3/2, 0. Right? 3.5. So this one, I probably should have, this one's probably coming up a little bit. And -3/5. So here, this one is 3/2, 0. This is my x-intercept. And then you can draw an arrow if you need to. That one is 0, -3.5. That's my y-intercept. So again, the big idea is this. We'll learn more about these. These are called rational functions. Everyone say rational functions. Rational functions are basically a fancy word for a fraction of an equation. We call this a graphing failure because in our graphing calculators it actually looks like they're all touching or attached, but they're actually not because they don't touch the asymptote.